All right, hi everyone, and welcome back. One of the things that people do and sort of ask me after studying linear programming or integer programming, binary programming, assignment, transportation, is they sort of make the realization, well, not everything is a linear problem, right? Like not everything is a line. So this is all great in theory, but what happens in the real world when you have lots of curves? And the beautiful thing about this, and you can apply this to nonlinear formulas. It's amazing. So if you master linear programming, then you can actually get good at all sorts of linear examples. Where things get a little harder, of course, is if you have more variables, you might need more powerful software to solve them. The algorithms in the back get a little harder, but for small examples, you can see how this works. And then if you ever need it, you can go learn more advanced programming or use more advanced software. So let's do this one. Pause the video, read the example if you haven't done so already, and then think about perhaps how you'd set this up. This is a brand new template for us. So if you want to give it a try, if not, work through it with me. Here we go. So let's call this a nonlinear example or nonlinear template. And one of the first nonlinear formulas you see, especially in statistics, is the formula for variance. So here we're just going to have two variables, x and y. We're going to keep things very simple just to develop a template, and then we'll see another example next time. But we have our two variables, x and y will be the things that we want, so we'll color code those green. And X will be the proportion of money to invest in a stock, and Y is a proportion of money to be another one. So here's the backstory if you haven't read it already. Ryan, a financial investor for PB&J, is evaluating two stocks in a particular industry. Wants to minimize the variance. So there's your objective right there. And notice your variance formula. Again, if you've seen this formula before, you know it has x squared. That's a nonlinear term. Something needs to be done about that. You want to minimize the variance of portfolio consisting of the two stocks, but you still want to have an expected return of 9%. And after obtaining historical data on past variances and returns, he develops the following nonlinear programming. Key here being nonlinear. So X is a percentage or proportion of money to invest in stock 1, and Y is the proportion of money to invest in stock 2. All funds must be invested. That's going to be a constraint that says that whatever your percentage is for X and Y are, they have to add to 100%. So all funds must be invested. So X plus Y has to be 100%. So we're still going to have our objective. This looks the same. And we're still going to have our constraint table. That's all fine. Historical returns on stock 1 is 11%. Historical returns on stock 2 is 8%. So we're going to use that to get our return on investment to get an expected return or average return of 9%. So how do I do this? I definitely want to minimize my variance in finance. For those who don't know, variance is like risk. So I want to minimize this. I want to minimize my variance. And the formula is 0.16 x squared, 0.12 xy, and 0.9 y squared. Where's the x squared? Where's the xy? Where's the y? And this is the beautiful thing about it. In the linear programming, we had our decision variables, we had our objective, and we had our constraints. The thing we're going to add now to our template, let me slide all this down for a little bit, is our non-linear variables. We had our non-linear variables. So which non-linear variables do we need? Well, I need x squared, I need xy, and I need y squared. Non-linear, by the way, here, there's lots of ways to create non-linear variables. Linear just means the variable by itself. If you put them together in any way, even x squared or xy or y squared, that is a non-linear variable. You can certainly do sine of x, e to the x, logs, all your crazy formulas that you know from math, you can put them in here. Excel has them all built in, of course. And what you're going to do here, remember, x and y are the things that we're trying to find, but we need x squared, xy, and y squared. So what we're going to do here is calculate this. These are going to be our formulas. This just says take x and square it. Okay, so x squared. Great. I need xy. I need x times y. Remember, use the asterisk for times. And then y squared equals y squared. And I'll show the formula. So you build them out. Whatever you need, you go and get them. Whatever you need, you go and get them. The variables that we're still after, x and y, those are still up above. These are your now decision linear. Our objective is then our variance. What I'll do now to set up the formula is the coefficients on these variables can go below. This is sort of the similar template that we had before. We like to see these things in cells. I don't want to bury them inside a formula. You can certainly go into variance and just type out the formula, but then you'd lose the numbers on screen. It'd be hard to check if you had a typo, something like that. So I do want to see these numbers out front. Again, the 0.16 corresponding to the coefficient on x squared, on xy, and on y squared. If you had other nonlinear, you would just go off and keep expanding this table to the right. But now we have sort of this is the new thing for this example, non-linear variable table. The variance formula is then the sum product of the variables, the calculated variables, the numbers, comma, the coefficients. And I'll show that formula as well. Notice if I put in some dummy numbers, if we just plug in some dummy numbers, let's say 2 and 3, convince yourself this is working. What is 2 squared? 4. What is 2 times 3, 6. What is y squared? 9. It's a little not as obvious to say what is 4 times 0.16 and 6 times 0.2 and 9 times 0.9 and add them up, but you can check that it does actually equal 9.94. So these are our dummy numbers. I'd love to know what the right answer is to minimize variance, but don't forget I do have some constraints here. All funds invested, what does that mean as a constraint? Let me expand the column. All funds invested means the percentage, now really this should be percentages, so this is going to be something like, well, let me just make this percentages. So 20% and maybe like 80% or something like that. Whatever the combination is, I don't want to come back and say 20% and 20%. I need all funds to be invested. So I'm still going to have 3 past my variables. Let's build out a constraint table. 3 columns passed, put on some borders. We'll do our left-hand side, we'll do our sign, and we'll do our right-hand. And all funds invested means that the amount invested, the proportion or percent invested in X plus the proportion invested in Y. Well, this has to equal, and we'll do single apostrophe equals just to show the equal sign. And this has to equal here 100%. And we'll do our sum product formula on the variables and the coefficient. So this is all the same from before, so I'm going a little quickly. Hopefully you're okay. But I'll show the formula over here for the left-hand side. So everything's the same. Just add up the 2 percentages, and because it says all funds must be invested, I really want 100% invested. I don't want 20% and 20%. To be consistent, you see here I have 0.4, so let's just make this a percentage, and we'll keep everything the same. So all funds should be invested. Great. And then I want this other expected return of 9%. So expected return of 9%. The historical return on Fund 1 is 11%. We'll put that in there. And historical return on Stock 2 is 8%. So we'll take our left-hand side. I'll put in my dollar signs here. I'll drag this down. And I'd love to have more than 9%. So we'll do greater than or equal to 9%. So we're working in percentages here, and that is totally fine. Percentages are just numbers. There are no other constraints here. Again, a simple example really to emphasize the new nonlinear aspect of this program. So we have a nonlinear variables here. And notice we use them. Where do they get used? Not the constraints, although you can imagine there could be examples where we need somehow a nonlinear constraint, and you would just refer back to this table, but really in the variance. Where they're coming from is being used in the calculation of variance. All right, so we're good. So let's go to data. Let's go to solver. And there's one small change here as well. Set your objective. This is your gray cell. For me, it's B11. I do want to minimize variance. Again, variance is your risk. By changing the variable cells. The 2 variable cells are not the nonlinear ones. Remember, these are just calculated. What you're actually changing is coming from B2 and C2, the green variable cells. Subject to the following constraints. Okay, let's see here. I have that all funds must be invested, so my left-hand side has to equal my right-hand side, 100%. Let's add another one. I want my expected return to be greater than or equal to 9%. That is okay. These variables here are not integers. Percentages are not integers. They're not binary. I do want like a number. It's not a yes or no question. But again, you can think about it. And then you're okay. I do want these things to be non-negative. It would be weird to come back and say invest negative 20%. And here's the only thing that's new. Before, I kept choosing simplex LP for linear programming. This is very specifically non-linear. These variables in here, the calculations in here, are non-linear. Solver has a built-in non-linear solver, GRG non-linear. So let's select that and hit solver. Found a solution. All constraints and optimality conditions are satisfied. We'll keep solver solution. And I have 93% to invest in X. They don't tell me the number or the budget, but just 93 of my budget in X and 7% in Y, and my variance, and this usually is reported as a decimal, although you could also do it as a percentage. Give back a reasonable number. It drives me crazy when students give me back 9 decimals or something like that. Pick a reasonable number, 2, 3, or 4 is fine as your variance. And then you'd write all this up in your summary. So just don't forget to include your summary sentence. Here there's no tricks about units or anything else, just a new template that we're going to build off of to wrap up the content of this course. So hopefully you see how this can expand. Go over this one, make sure you understand it. Great job on this example. I'll see you next time.